In our earlier discussions of energy, we learned that there are two types of mechanical energy, kinetic energy and potential energy. And we learned that kinetic energy is the energy of a moving object. And so what happens when the object is spinning and not moving in a straight line? Our equation for kinetic energy of moving in a straight line is 1/2 mv squared, where v is the speed of the object. But what about an object like a Ferris wheel that is simply spinning on its axis? What speed would you associate with that object? In this case, when we're talking about things that are simply rotating or spinning, we refer to a rotational kinetic energy, which is the energy, again, of motion, but of a rotating object. As before, kinetic energy is a scalar, like all forms of energy. The symbol is Ke, just as it was before, but we give a subscript of ROT, just to designate that it's rotational kinetic energy. All units of energy are joules, so this is no different. But the equation, instead of 1/2 mv squared, instead of mass for inertia, we use the moment of inertia. And instead of linear speed, we use angular speed, and it is still squared. So the equation is similar, 1/2 I omega squared, where I is the moment of inertia in a kilogram times meter squared, and rotational or angular speed is measured in a radian per second. You must be in radians for angular speed. So we have our two different types of values that we are going to use in our equation. Some examples of things with rotational kinetic energy would be like this yo-yo. It spins as it moves in a straight line. So it has both rotational kinetic energy and the old type of energy, kinetic energy, which we call translational. So translational, which just means linear, means in a straight line. So it has both types, rotational and translational, because it moves down the string and it also rotates. Same thing with the Earth. The Earth spins on its axis, has rotational kinetic energy, and also moves around the sun, so it has translational kinetic energy as well. So a lot of different objects have both types. Objects that have only rotational kinetic energy might be something like the Ferris wheel that we had given an example of before. Perhaps it would be like a merry-go-round, which is not moving linearly, but it is only rotating.